Those thin feather-like streaks high above Australia are not made of raindrops. They are mostly tiny ice crystals, forming in some of the coldest air of the troposphere. Cirrus clouds usually sit above about 6,000 meters, where temperatures are low enough for water vapor to become ice. From the ground, they can look delicate and harmless, but they reveal a lot about moisture, wind, and weather systems high overhead. The key process is called deposition. That means water vapor changes straight into ice, without becoming liquid water first. In the cirrus layer, the air may become supersaturated with respect to ice. In plain language, there is more water vapor available than the cold air can normally hold, so ice crystals can grow instead of shrinking away. Ice often needs a starting point. In many cases, the first crystals grow on tiny particles, such as dust, soot, or mineral fragments. This is called heterogeneous nucleation. It is the easier and more common pathway. In extremely cold, very moist air, ice can also form without a seed particle. That is called homogeneous nucleation, but it needs much tougher conditions. Once the crystals exist, the wind decides what the cloud looks like. The jet stream, a fast river of air near the top of the troposphere, can pull cirrus into long, thin streaks. Strong upper-level winds can spread the crystals across a wide area, making the cloud look feathery from the ground and smooth or banded on satellite. Thunderstorms are another major source. A strong storm can punch moist air high into the atmosphere, then spread it outward as an icy anvil. When the storm weakens, that leftover ice can drift away as thicker cirrus spisatus or as thinner cirrus bands. This is why you can see high cloud long after the thunder and heavy rain have moved on. Tropical cyclones can do something similar on a much larger scale. In northern Australia, strong outflow high above a cyclone can spread ice crystals far from the storm centre. You might see a bright high shield of cloud before any rain reaches your location. Dust from dry inland areas can also provide particles that help ice growth begin. Cirrus matters because it changes how light and heat move through the atmosphere. Thin cirrus lets much of the sun's energy through, so the day can still look bright. At the same time, it can trap some outgoing heat from the surface. Thicker cirrus can dim the sunlight more strongly and give the sky a milky look, especially around the sun or moon. To spot cirrus, look for very high white fibrous streaks, hooks, or veils. They may appear ahead of a trough, along the edge of a jet stream, after thunderstorms, or around tropical weather systems. Cirrus does not always mean rain is coming, but it is a useful clue. It tells you the upper atmosphere is moist enough for ice, and that strong winds aloft may be shaping the next change in the weather.